Welcome. Okay, so today's order of business. Got to work on the standard library. Unfortunately, I have not been working on it recently, but it's kind of been erratic. My pushes anyway. So we'll actually, you know what? Before I do this, I need to just make another window real quick, or virtual desktop. There we go. That should be good. So, yeah, my work has been erratic so far on this. So it might seem how do I say it? Might seem weird, truthfully, as to how I'm actually working on it. And some of these things might seem like, I mean, well, inefficient, whether actually inefficient or, you know, informationally inefficient. Not these, but some of the different types actually just ls. Yeah, with stuff like the any type and stuff, it might seem inefficient. But that is one of the tools which I'm actually using. Basically, the thought is for it to be used as a legacy device to more easily swap things over from other languages. So for the any type specifically, that's of course going to be like duck typed languages. So if you wanted to port something from Python to Y, that's one of the reasons. Just to, you know, get it working quickly so you can tell, you know, that it's working, and then do the actual refactoring later. I have a few things like that that are maybe inefficient. Definitely the bit stuff, like a pointer to a bit and things like that are definitely inefficient. At a bit arena, stuff like that. I'm not sure how useful they would be, but I I thought maybe there would be some use out there, since we use byte machines, and we address by the byte, not the bit. Might be nice at the very least to play with. So I think first things first. I'm actually going to make a global to-do board, if you will. As you can see, I've already made the file. Well, actually, before I do this, I should see. I don't remember. Okay, I didn't have any actual syntax here. So I need to make 1 second. Okay. So I need to think about exactly how I'm going to so I need to think about how I'm going to I think I'm going to pull all of the to-do stuff that I have from all of the other you know what? Let me actually see real quick where I actually have any to-do information. I don't think I have. I only have a few. So, but I should pull it all together. I have some in the bit stuff, but truthfully, I'm not going to move that. I am though going to move this one. Oop, let me go into insert mode first. There we go. So let's see. So the first thing is finish our array, and truthfully, the rest of the collections. The base collections, like, I have a singly linked list right now, I think, so I need a doubly linked list. Definitely a hash map. Obviously gonna put data structures like stack and all that stuff in there as well. Actually, I'll just leave it like that for right now, since I don't have the files in there currently, but yeah. And I probably should also move them into sub-libraries at some point. I'll have to see. I also have some. would say, well, I have some old syntax as well as some educational material that isn't actually technically part of it. So I need to change that at some point. Let's see. That was example section. I really have to update this syntax at some point. Or at least with some of these files. They don't really have the latest syntax. Oh, here's one. Okay, cool. Yeah, I definitely need to determine whether this syntax is okay. There we go. Paste. Oh, actually, that does need to be there. Yeah. X. Actually, that does work. Delete this. And then I'll just put this on the end. This should be fine. Okay. Oh. Yeah, I don't know if this syntax really should be allowed. I've still gotta think about that. Let's see. No, that should be fine. That's just a ternary. Okay, yeah, that needs to be. Paste that. Determine whether range can be a struct. That would probably require changes. I'm not quite sure yet. Depends on exactly how I do that. Range array. Nope, I already did that. So that should be everything, at least that I have in the files currently. And let me actually order this. Should order it. Probably most, yeah, I'll order most abstract to most concrete. What is it again? Oh, $, not underscore. Wait a sec. Yank, paste. Deal with namespace collapsing and stuff. Yep, that is. These are kind of the same, but I guess I'll treat this as the top one. V ink paste. Paste, and then the last one. Yank P. Alright. So 5 of them. Okay. There we go. I'll leave an empty line at the end of the at the end of the file. Why not? Because I definitely have other things that I'm going to need to add. Especially with stuff up here. But yeah, that should be everything, at least from the files. I might go back and put what file these are from later, but I have other things that I need to also do. There we go. So one thing I need to do is actually well, I can't actually write them yet. I mean, I guess I could put down the declarations for print and things like that, because obviously those things are necessary. Yeah, I'll just print and other things. I'll just do the other basic things that you know, the C library does, that everyone thinks about the C library. Though I do have a slight difference with that, as I will only be printing strings and formatting will be separate. But yeah. I can make the formatting stuff. I guess for right now, I'm gonna do for the basic types. Oh, wait a sec. I need to look back at. I had a poll. Let me look and see. Yeah, I'll just put that stuff on here, because I've already got object. I've already got anywhere pointers, which, if you don't know, are supposed to be basically, if you don't know whether what you're going to return from a procedure is allocated on the stack, well, either in a place that gets cleared usually during the runtime of the program, like the stack or the heap, or if it's going to be in the data segment, like you have just a static list of things that you declare somewhere. And these are actually the different, I don't know how well it works here. But I guess I can, that's, oh, no, it does not work well there. But basically, that's the list, and it was voted for, what was it, 5 and 6? Yeah. So those are things I'm going to work on first. Yeah. And what was the other one? Networking, right? Yeah, networking. Actually, I should put this on separate lines. And, I think the rest can come after that. IP address will go into the networking utilities. But maybe I should start making this a little bit more whatchamacallit? Yeah, maybe I should actually make this into a few different sections at this point. I mean, I already have the system section down here, which that's probably gonna be the last part that I work on. But the networking stuff and oh, it's been so long. Is it buff? I don't remember. Yeah. Maybe I just make the formatting stuff, because that should be pretty easy right now. The things that I had in the actual files, I think I can probably get away with waiting till later. But well, these things I can probably start setting down, and then of course I need to I already said finalize syntax and refactor the standard, but I also need to so update syntax in library and oh, what was the other thing? Oh, yeah. Remove demos, etc. from the library, and yeah, I'll make a new I'll just make a whole file for it, and then I'll deal with it later. Okay. Oops, I forgot. Buff. 40 up. End of line. Yank. Buff. Format dot y. Paste. Oh, it's been a while. I think that's the date. that's the date. Okay. I think I might have an alias. Yeah, I might have an alias of F. But I have to deal with aliases first, because they're nowhere here anyway in the library. But I'll do... I guess for right now, I'll just deal with... Yeah, I'll just do it as ASCII text. Actually, wait, I think it works as ASCII text anyway. I don't think I need any... Yeah, I'll just do ASCII array. Yeah, because this is an abstract function anyway, or abstract procedure anyway. So I'll take in anything. I'll call it data for right now, and I will output some ASCII array that formats the data. I probably want a separate one for dealing with like formatting specifically real numbers and stuff like that, to make sure it doesn't print like 20 characters out for each double. But I think for right now, that's probably... It's probably fine. ASCII array. Yeah. Probably also need a type switch, but I should be that, or is it type of... And this is why I need to finalize things. I don't remember at all. Oh, I will change to that though. So, what am I looking for? So if it's a number, this only do the basic types at first, I guess. I'll deal with, like, I of course have plans for arbitrary sized numbers, but I'll just deal with basic types at this point. So I have to deal with, well, actually I guess I could just deal with integers No, I have to deal with them separately. Yeah. Right. Because I have to turn them into... Well, the most efficient way would be to turn them into, what, binary counted decimal, I think? And do a BCD instruction. If I remember correctly, it's BCD on Intel. I'll just start with the naturals, I guess. I'll deal with integers later. Oh wait, I can't define this up here. If I Well, this is another question. So, since this is an abstract procedure, I could choose to have this be of abstract type, and then only based on the type of the input would the type of the output concretize. So for naturals, I could choose, you know, an array long enough for some natural size. Say like, you know, a classic natural of 8. I could just make this array be, you know, oh, what's the, it's like 4 billion or something, 4 billion big. So the array would be, assuming this of course changes it to decimal, which I'll have to choose to do elsewhere. Deal with different bases. I could just use an array that's, what, 12 long, approximately. I don't remember, is it 4 billion? Yeah, it's something like that. And I could do that. Which, seeing as it's an abstract procedure anyway, I might want to do that, because then I can be, well, yeah, I might want to do that just because then this can be placed in, say, like the data segment, because it has a concrete type at compile time. So, but then I can just base the type off of, or the actual size based off the actual, fully based off the type. And then I can have maybe. I'll have to. I might. Well, I'll definitely have to change this syntax. But basically, then I can get. I can base the length of this array based on the length of this number. So, oh, what is it? How many decimal places do I need based off of, it's 8 bytes of information. So, that can be, thought of as base 256. So I guess three. Right. Because it's 4 billion. Let me get out a calculator. Let me see. Does this one have a programming mode? Yes, it does. And then I choose decimal, but no. I don't want to input in decimal. What? Okay, yeah, I was wrong. Cause that one is what, 2 billion for, yeah, that's 32 byte. I should have I thought that was what it was. So 64, that's a yeah, quite a big number. Let's see. How many? That's 18. 19 places, I guess. Oi. I am too tired to do this today. Let's see. Okay, yes, in base 10, that is 3. So 1, 2, 3, 4, 5, 6, 7. 7 times 3, 21. It's 20 places, but I could say 21. I mean, I guess for, you know what? For right now, I might as well just say a number that includes it, but isn't it, just to continue rolling. So 8 times 3 is 24, which that'll be fine. Obviously, it's too much, but, you know, I'll go back and actually do the calculation sometime. I do not have anything next to me to do this calculation. Okay, so with the size set correctly, or, well, at all for right now, now I can start doing the actual thing. Oh, how do you do it again? I mean, the most efficient way would be binary counted decimal, I think. I think there might be a vector operation to do this. You know what? Since this, actually no, I'll look through and find the vector operation, because it shouldn't take long. Let me get up. I have the PDFs, manuals, and references. Nope, that's the optimization reference. Here we go. Software Developer's Manual from Intel. Instruction set, volume 2. Instruction set reference, A through L. M through U, and V through Z. Okay, and so I need to take... Okay, let me go to the original instruction. Maybe I'll just use that for right now. If I can't find the vector instructions, I think there is, but I'll have to deal with that later. Did they remove this, or is it not here? Bitfield extract, blend packed double precision floating point values, blend packed single precision floating point values, variable blend packed double precision floating point values. Variable blend, blah blah blah. Extract lowest set isolated bit. Extract lowest set bit from RM32 and set that bit in R32. Interesting. I might have to remember that for later. Sounds like a very, very good instruction. Get mask up to lowest set bit. Another instruction that seems very useful. Reset lowest set bit. Check lower bound. Check upper bound. Let extended bounds. Make bounds. Move bounds. Store extended bounds. Check array index against bounds. Bit test. Bit test and byte swap. I could have sworn there was an instruction for this. Did they deprecate these instructions, or do I not? Is it not actually BCD? Maybe it's not actually BCD. Let me look in another place. References, yes, there we go. Links x86. See me. There we go. 8086 instructions. Let me. Oh, that's what it is. It's not. It's not in the B's. That's why. It is ASCII adjust after subtraction, ASCII adjust after multiplication, after division, after addition. And so those are the adjustments. So I can add them together and then do the actual adds. Now where's the actual convert to? It is D, right? Decimal adjust after addition. Corrects the result of addition of two packed BCD values. And what is that? Corrects result. Yeah, so AAA is for correcting results when they're already in BCD. Wait, no, wait. It works according to the following algorithm. If low nibble of AL is greater than 9 or... Is it just... maybe it is just that instruction. I don't remember. It's been quite a while. since I've looked at these 8086 instructions. Um, yeah, I don't think. As if I let me just search BCD in this page. Yes, that'll be the first 4, and then is decimal just after subtraction. Oh yeah, okay. So these are the only instructions that deal with oh, okay, I see. So the actual to convert into BCD, use ASCII just after addition. And then to convert back, use ASCII just before division. That's what it was. And then there's a few different things. For doing other things. Okay, yeah. So all I need to do is do ASCII just before addition or after addition. So that's AAA. Let's see. Does this instruction even still work on modern processors? 64-bit mode invalid. That's great. Okay. There's gotta be a newer version. Let me see. There's gotta be some type of one that converts it into a vector, I'm thinking. And I think that would be the clearest way to go about this. Like a vector of individual bytes. Or maybe one that converts to a vector of 64-bit values to like splay out the 64-bit value into 8 64-bit values. So then you can, that one probably for Unicode. If you want to convert a number into Unicode, I'm sure do something like that. Convert with truncation. These are all conversion ones. I don't want to convert. Wait a sec. Convert packed double word integers to packed double precision floating point. No. No, that's a different instruction. Okay, what do I need? I need convert a single. Now, these are all vector instructions. Oh, wait. Store BCD integer and pop. Converts the value in ST0 register to an 18-digit packed BCD integer. Stores the result. But this only works on... This only works on floating point values. I would much like to do this much. Okay, well, you know what? I'm just gonna have to. I'll have to find out where this instruction is, because I swear this instruction actually exists. Or hopefully exists. Though it definitely seems like it would be very useful. And since they deprecated ASCII adjust after addition, you think they'd have something to do it, something to replace it with, since it's still an operation that needs to be done. So, I guess in the meantime, I'm just going to write here, find BCD instruction slash it's either going to be a BCD or vector instruction. Well, technically it's not a vector instruction because it's not working on... It's not actually doing... You know, operating on separate pieces at the same time, but it would be some type of conversion. I'll put this the other way around. So, vector conversion slash BCD. I'll just do more BCD instruction. Certainly have it in there somewhere. Same thing with integers then. I'm not going to do integers right now, but I might as well start doing other ones, which I can still do, even though I can't find that instruction, because I can just make this recursive. Did I have this one? I don't remember. Maybe I don't have else in the... Did I forget else in my Vim formatter? I'll have to deal with that later. So what else? Pointers. Well, technically pointers. I want to keep them in hex form. For right now, I might as well just do forms that actually hold other things. Let me do... No, I can't do doubles right now either, but assuming I have doubles and naturals and integers all done, I'll have to find the instructions for them later. I will do... what is it? It's after, right? Yeah. Start with complex numbers. Yeah, because complex numbers, pretty easy. Basically, all I need to do is The question is whether I print it out in... Yeah, I'm gonna print it out like this. So if, assuming data is a complex number, then I'm going to format data. Oh, how I don't remember how I'm setting this up. Eh. Maybe it's A plus BI. I'll go with that for right now. I'll just return format of A plus format of B. And then also include the character I. Oh, I also need space plus space. There we go. Right. Actually, no, I'll take out the spaces. Yeah. Yeah, that should be fine. I'll deal with making this stuff more generalized in the future. Just kind of want to get some stuff on the page, you know. So, well, you know what? I'll just do split complex and do J. That's easy. I mean, basically the same thing. Wait, so complex numbers, split complex numbers, quaternions. Yeah, I think I'll do quaternions next. Oop, nope, oop, that's wrong. Shoot. What's it? C quaternion, and then I basically do the same exact thing, but I have yeah, I guess I'll do A B C D just for right now. Yeah, it should be fine. And I'll like I said, deal with this later. To actually get it. Oh, paste. And then A plus BI plus CJ plus DK. I think that's the usual form, but right. Okay. I don't think I have Um, oop, yeah. I don't remember if I placed an actual octonian. Let me see. Octonian. Oh, I did. Okay. Hmm. You know what? I won't do that now. I'll just put that in the to do. Why not? End of line. C. Oh. It's also, I'm actually not sure, because usually once you get up to octonians, you stop using I, JK, stuff. You start using basically E, which is well, it's better to say it's an identity, but it's not actually an identity. But yeah, you start using E with subscripts, and it's kind of hard to do subscripts on ASCII text. So, you know, I'll I'll see what to do with that later. Maybe I'll do something like E and then continue with other letters. But if I V okay, so what's the next part? I have vectors, so vector. I think I might do it. Yeah, I'll do it the way in. So I can do it with like an ordered pair with parentheses. But since they're vectors, and specifically vectors, I think I'm going to use angle brackets, like in usually used for physics notation, because I like angle brackets for my vectors. Oop, there we go. Okay. And yeah. Okay, so and this is the part. Yeah, so this part. See, all the other parts, I guess technically, since the size, these forms all work, no matter what size of object. So if I had or type, if I had integer complex number or real complex it wouldn't matter. Because then the actual variable size would be in these further recursed formats. Because the plus and the and the I and whatnot don't actually matter when dealing with, because they're just characters. And well, actually, yeah, these should be. I had to think about that one, about whether to. They might have to be strings, but I'll deal with that later. Maybe I'll make it so that it works with characters. I don't know. So at this point, down here, I have to format each number, but since it's a vector of arbitrary size, I do actually have to do something different. So yeah, I think I'll do that. I'll do I'll make a format size procedure, which I will deal with at a later point. That will actually, I'll use this to give me the length that I need of the ASCII arrays. So I can do ASCII array, because I need this to be concrete once we get here, which it, of course, since this is an abstract procedure, it's kind of gets a bit weird about when things are concrete and when things are still abstract. Like these, data.a's right here are types that we actually don't know at this point, because all we know is that data is a complex number. So data.a has to be a different type, because complex composes types. So it could be composed upon a natural number or an integer or whatnot, or a real number. So I don't know that. I don't know the type of A at all at this point. Now, this is an abstract procedure, so this will have to be done at compile time. To find this. And I mean, part of that is this is if-else if block. But and other things, of course. But it gets a little, weird, I guess, in here. So ASCII array format. So actually, do I need? Actually, no, I don't need. I don't need to do this at all, do I? I could just keep. Yeah, I could just keep going around. Just make it an empty array and then keep. Can't I? No, because that'll No, because I can't plus equals. I can't plus equals with an array. So actually, what size is this going to be? So it'll be 2 characters. From the angle brackets. However long. I guess I could. Yeah, I could just send in data, and then I was gonna send in like data of 0 or something, but actually, it's much more succinct to do this and then let format size also be recursive. Yeah. So ret, and then I'm going to also return ret. I guess I'll do this for right now. Ret of 0 equals angle bracket. And then I'll do a for loop, and then I'll do ret of what size of size of size ret, right? No, because that's in what? Well, actually, I am doing in. Well, I guess this works, but isn't the most actually explanatory. I'm not dealing with the number of size in bytes, but because I'm dealing with ASCII arrays, it happens to be that. But I'll just do that for right now. I can't remember. There's something else I have for that, but I'll just do it. So the length of it -1 is not that one, the other angle bracket. And then I will go down to there, cut, and return ret. And then now what am I gonna do? I have to place this in oh, I should also do the last one down here as well. Ooh. And this is why I need to calculate it correctly, because actually maybe I need to trim out 0 characters as well, though. Because if I get a natural number, let's say like 1, and I have a 13 long array, and I'm going to have zeros in there. I don't want to keep pushing through lots of characters. Yeah, so maybe instead of the last character, I'll just keep right here. Actually, I'll just keep right here. Natural. Let's do I for index, I guess. And the last one I'll just do as index. And then so I can cut off. Maybe I'll have to move all the returns. And I'll have to cut off, or before returning, I'll cut off the last null characters. Because I don't want to send null characters through. That's just going to make, especially with this being a recursive procedure, even though it happens at compile time, like the sizing and different stuff like that, and which path, it's still, I mean, I still don't want to be sending through more information than is necessary, since that's just going to slow down compilation and the actual runtime effects of this procedure as well. When it goes like, oh, I sent in a matrix, you know, so its format of matrix is called, and then it calls, you know, format of natural, and then it calls format of, you know, and all this type of stuff where it's just, it'll be less efficient overall, and I'll have to do that with these then as well. Well, no, if I take off the text up or the empty characters before returning, I should be fine for all of these, the complex number ones and quaternions and stuff. But yeah, so if I do natural C equals 0, C, what is it? I'll just do, for right now, I'll just do the classic, I guess. Again, I don't remember, so I'll just do this, and I'll get back to that later. So, yeah, less than, and then I do, inside of here, I need to format, how am I gonna do this? Since the thing is, like, how does this concretize? And I can't have an array that has arbitrary size. That doesn't work. At least not an array. You know, like in the data segment. stack. And I can have an arbitrary array on the stack, but it's not great. Oh, how do I deal with this? I mean, I guess I could unroll, and this would have to be during compilation. This would have to unroll the for loop. I mean, I guess, seeing as it has a defined not just number of loops, but also the actual order. Because it could be defined 0 to 5 and then 10 to a million, and that still works. It's defined. It's fully defined, instead of something like if the condition was, because the condition here relies solely upon the loop counter and a number that isn't concrete right now as I'm writing the procedure, but would be concrete when the procedure is called, because it's part of the information of the actual type of the input. So maybe I say this is able to be unrolled if it has... I mean, I'm already unrolling unrolling loops to get more, to make them more efficient already. I guess maybe this is, I have to unroll it if it contains something like ASCII array. Like an abstract, a variable with abstract type. Maybe I have to unroll it. Maybe I make it so it can be unrolled, and then since it can be unrolled, I have to unroll it to actually make it work, because at runtime it has to have concrete type. So I would have to make, like, although I would then have C, or I would have that many temps, maybe. Or I guess I could overlap them like a union in C. I mean, maybe I could get away with that, because I would have... Yeah, because I'm already saying stuff like giving warnings if you use uninitialized variables. So maybe I can just make it so this all of the loop one, and it makes sense because it's supposed to be the same variable, even though it can't concretely be the same variable. I could still have it be the same variable by being at the same location in memory, because it also only lives for, quote unquote lives, if you want to use C++, terminology, for the time of the loop. And so the next go through the loop, I should be able to it will be gone, and then I could have another one just at the same location. Yeah, that should work. And I'm actually going to let me put that over here. Abstract loop must unroll and unroll completely. What, completely? Maybe not completely. Actually, I might not actually, because if I put temp at the same location, I actually wouldn't have to unroll this completely. I might not even have to unroll this at all. Then. Though I would have to do some trickery with some of the things that aren't seen, like the type sizes and stuff like that. That might get passed to procedures. The very few pieces of information that are unseen, only because it is implied with all the rest of the stuff. Like with an input, it's implied that the type, is going with it. In these abstract procedures. So actually, I'm not going to say must unroll. I'm going to say variables of abstract type so variables of abstract type that are within get this doesn't work with multiple though. So I have multiple abstract variables with abstract type. It won't. I can't place them both at the same location in memory. As they were the original way through, because it could be that one would then be, 5 before another, but now it's, 28 long, and it would overrun the other one. So this has to work with only one? Maybe I'll just say for right now only works with one. But yeah, so I'll have to say it's only one variable, and I guess I could do it like, I'll have to do it like C's variadic things probably, where it's just the top thing on the stack. I think that will work. Because I can't place it anywhere in memory. Unless concretely it I know it will be below a certain size, which I guess could find. But then it's also, this only happens at compile time, so it's really not all that necessary. Each time through the loop. Okay, and then pretty simply, I just do, that pretty simple, I just do format of data of C, and I get the formatted first value, and then you know what, I'll also add on the, the comma there, and then I just have to place that in. No, because format should be the correct size now, assuming I get it the correct size for the other things, then I actually don't need to deal with this. Right? Okay, well, the format size, though, I will have to, yeah, I'll have to make sure of the correct size. But other than that, everything should be fine with that. And then this last one, I can do the same with, instead of an abstract type, using type inference. ASCII array L, I guess. Format of data of SA -1. And then I'll also do -1 here. Yeah, sure, I'll do -1 here. And then I just need to place them into ret here and here, which oh, I have something for that, don't I? Well, I'll place temp in ret. I'll just put those right. Put those there for right now, since I think that's gonna be it today. So but yeah, I'll continue continue working on this later. And get a few of the other stuff. I also need to send this into the repo soon. I need to get another key. I'm using the key thing so I can use GitHub from the terminal using Git, and already expired. But yeah, so I'll deal with this later, and I will be back another time. So farewell. It's been a while since I looked at this OPS. Okay, there we go. And goodbye.